Okay, so in the previous class, we did learn about fundamentals of the light. We did learn about some of the important characteristics of the light. Before we continue, today, like our discussion would be mainly focused on reflection, types of reflection, laws of reflection, and the different types of reflecting surfaces. Okay. Before that, you guys tell me what are the important characteristics of light which we have discussed in the previous classes. Yes. And it is recommended that everyone turn their cameras on in the class. Yes. My question was now, what are the important characteristics of light, which we have discussed that in the previous class?
Sir, color.
Color, I didn't get it. Like, what do you mean by color? Yes.
The important. Yes.
You are trying to explain about the dispersion, rainbow formation, a spectrum. No, not that is like light. Continue.
So light travels in a rectilinear motion.
Or basically light follows rectilinear propagation. Okay, and it does. It's rectilinear propagation is the property of light, which says that light travels in a straight line. Okay, and yes, Gauri, Roni, Khadija,
It can
Abdullah.
travel through a vacuum.
It can travel through vacuum also. Very good. So thereby, if it can travel through vacuum, so it does not require a medium to travel, right? So what kind of wave
Can form energy by luminous object.
form energy by luminous object? Basically, on the basis of what kind of whether an object will be giving its own light or whether it will not be giving its own light, there are two type of objects: luminous and non-luminous. Okay. Yes. Shakari, Gauri, you also mentioned some of the points. Roni. Yeah, we learned about different characteristics of light. We learned about the speed of the light. We learned about some other phenomena as well. Light will be reflecting from the smooth surfaces. Light will, when it will be passing from one medium to another, so thereby it will be doing refraction, it will be refracting, right now. Also, as I was discussing that since light does not require a medium to travel, so it will be traveling in the form of the mechanical waves or in the form of the, what do you say, electromagnetic waves. No, Chakrika, that is not correct. It is not a mechanical wave now. Transverse wave is an is one of the type of mechanical wave. Mechanical waves were of two types, which we have discussed. Mechanical waves where respectively you have the longitudinal waves and transverse waves. These are the mechanical waves which requires a medium to travel. So light is not a transverse wave, okay? But light will be traveling in the form of electromagnetic waves because they don't require medium to travel. Okay. What about the speed of the light? Yes, Roni, you tell me what is the speed of the light? Yes. Okay, Gauri, you tell me what's the speed of light?
Sir, can I say?
Yes, Khadija.
3 lakh.
2 lakh.
Unit is, what's the unit? 3 lakh kilometer per second, no? Okay. By the way, 2 lakh something you are saying, na, Abdullah, approximate value is 3 lakh. Okay, now we take the approximate value. Okay.
You can't say.
Got it. And as for other properties of the light, we have learned that like it will be traveling in the form of electromagnetic waves. We learned about the speed of the light right now. So it is about 3 lakh kilometer per second. We learned that it has two nature. It has dual nature, right? It acts as both wave and particles. We learned about that, about the dual nature of the light also. In order to explain some phenomena of light, we will be considering light as wave. But to understand some of the phenomena like a reflection, light will be considered as particles. Okay, now that is one thing. Also, we learned that light will be doing reflection, refraction, and dispersion. Light will be dispersing also. So those are the important characteristics which we have learned. Further, we also learned that why light is necessary, why light is required. So you guys answer some of the, tell me what are the reasons, what are the requirements of light, why light is necessary. Yes, Gauri?
So we are able to see the objects because of light.
Okay, good. And Roni, Abdullah, Khadija, Chakrika.
There we can see objects properly.
Yeah, basically we can see objects whether it be properly or not properly, but nonetheless we can see objects because of the because of light.
And sir, if it's natural light like from the sun, then it also helps with photosynthesis.
Exactly. So natural sources of light like sunlight is required for photosynthesis. Very good. That is one thing. Also, like natural source of light, that is sunlight, will it also not be used in energy production?
Yes,
Right now,
sir.
like in the solar panels, the solar energy will be converted into electrical energy. So that is also one such application of light. Right now, also the sunlight has heat in it also, which warms up the planet. So it is important for the life. So there are several reasons why light is important. In the previous class, we did also learned about how we see the objects. So as the light rays will be reflected from the objects, it will be after reflection, it will enter into our eyes. As it will be entering into the into our eyes, or take a look at this one here. As the light rays coming from the CFL enters into our eyes, it will be passing through the eye lens, and there it will be refracting. Basically, it will come to merge at a point where the where the image will be formed. It is not image formation in the eye does not take place just like how the image formation in a plane mirror takes place. Okay, now. So here what will happen? The point where the light rays will be converging, where they will be meeting at a point. So there are some spatial cells called as photoreceptors, which are present there on the retina. And now the information will be sent in the form of electrical impulses via the optic nerve to the brain, and the brain will be interpreting that image. So that is how we are able to see the objects. Okay, now today we will be learning about a reflection. Okay, so as we know that light, there are different phenomena associated with light: reflection, refraction, dispersion, polarization, etc. So reflection is one of the phenomena associated with light. So in this, what happens that when light will be striking a surface, it will bounce back from it. Particularly when light will be striking, striking a very well polished surface, so it will be getting reflected, and if it is getting reflected from a polished surface, then it will follow some law. It will follow some law, right now. So reflection is basically that light gets reflected from the surfaces of objects, and any surface that is well polished or is shiny will be acting as a mirror. And the phenomena of light bouncing off the surfaces is called as reflection. No matter whether the surface is smooth or whether it is rough, reflection will still take place. Right now, otherwise you wouldn't be able to see the rough objects if reflection were not to take place from them. Everything that you see around yourself, you are able to see because reflection is taking place. Without reflection, we wouldn't be able to see anything. So in our surrounding, not every object is shiny, not every object is well polished, right? So reflection will be taking place from the rough surfaces also. And here in this image, you will see that different kind of reflection will take place. Okay. Say for example, if there's a smooth surface like this, or there's a calm water that is not moving, it is stationary. So in this, what will happen? Regular reflection will take place. Regular or specular reflection. As you can see in this animation here, this is an incident light. This is an incoming light ray. Because understand ray of light, no? Ray of light and beam of light, the difference is clear or not?
No,
Terms. Okay, no. So beam is basically a group of ray. In mathematics, you would have learned about the ray, right? Ray is basically a line which has an origin but no ending, like this. And when you combine different rays of light, then it is together called as beam of light. Then that is called as beam of light. So a ray of light is falling upon a smooth surface and it is getting reflected. It is bouncing off from it. Okay. And in this case, in the third image you can see here, or in this animation you can see here, as a ray of light is falling on the surface, and the surface is not a smooth. It is rough surface. Okay. Here in this animation, don't take a reference from this because this one looks like just a smooth, but it is a rough surface. Okay. So thereby, it will be getting bounced back into different directions. It will bounce back into different direction, as you can see in this here. This is a light ray that is falling on this surface and it gets bounced back into different directions, into random directions. Okay. So it's different kind of reflection can take place. We categorize them as regular reflection and diffuse reflection. So whenever light rays will be falling on smooth surfaces like a plane mirror or a water dot that is not moving, so thereby regular reflection will take place and a smooth image will be formed. And a smooth image is smooth and a sharp image will be formed. Right? Many times, if you were to stand nearby to a lake, to a pond, which is in which the water is stationary, so you will be able to look your image into the water, right? Okay. And diffuse reflection. So, for example, if you were to stand nearby the river in which the water is moving, will you be able to look at your reflection in the water?
What's the?
If you were to stand nearby a river in which the water is moving, so if the water is moving, so thereby the surface will be like this. So, will you be able to see your image in this?
No.
No, right? Because the surface is not a smooth. But if you were to stand near a pond in which water is not moving, so you'll be able to see your reflection in the water. You'll be able to see your image forming in the water. So with some real life examples also, we can relate to this regular and diffuse reflection. Okay. So diffuse reflection will always occur on a rough surface and light will be scattered into different directions. And image formation will not take place in the case of diffuse reflection. So is that much clear to everyone or not? Please let me know. Yes or no? Any questions?
No, sir.
Okay then. Now, we'll be learning about mirrors later. Okay, na? We'll be learning about mirrors later, or just it's a small topic. Let's cover this. Okay. So see, there are different types of like a mirror will be basically a very smooth and shiny object in which you can see your image clearly, right? So there are different types of mirrors: plane mirror, concave mirror, and convex mirror. These are respectively three different types of mirror. These are three different types of mirror. So the one that you're seeing here, this is the plane mirror, and these images shows you the concave and the convex mirror. So that one here is the convex mirror. This one is the convex mirror. This you might have seen, it will be installed in a mall or in some offices. It will be installed at the corner of the room. So it will be acting as a security mirror also, in which it has a wide angle view. So you can see in this one also, in this just a small piece of mirror, it is covering a wide area. Right now, the image of the wide area is being formed in this. Getting it, guys? So that is the convex mirror. The reflecting surface of the convex mirror, the surface from from which the reflection will be taking place, it is bulging outward. Let me draw this. That will give you a better clarity. It is like this. Getting it? So that is the case of the convex mirror, in which the reflecting surface is bulging outwards. And the third type of mirror that we see is the concave mirror. That is the concave mirror, in which the reflecting surface will be curved inwards. It will not be bulging outward. Getting it, guys? It will be curved inward, right? And these curved mirrors, respectively, concave and the convex mirrors, have a wide range of applications. They have a wide range of applications. So for example, the convex mirror that we have learned right now, moments ago. So it will be installed in several places, like it will be installed in malls, in offices, in ATMs. That will be acting as a security mirror, right now. It will be used as a rear view mirror also. Rear view mirror, you guys understand now, the mirror that is installed at the side of the doors of the vehicles, right? So that is the rear view mirror. And in the rear view mirrors, you will see that it will be written that the objects in the mirror are closer than they appear. Have you guys noticed that?
Yes, sir.
The type of mirror that is involved, that is this rear view mirror that is installed in the vehicles. So convex mirror is used there. Convex mirror is used there. Okay. And convex mirror will be forming smaller images. What does it does? It forms a small image, right now. So thereby it can be used as a rear view mirror or side view mirrors to help the drivers avoid from accidents. So it will be forming the images of the vehicles that are behind the running vehicle. It can also be used in the street lights. Okay. There also it is used. It is used in making sunglasses as well. And also it is used in making telescopes also. In the telescopes also it is used. That is one thing. Talking about the concave mirror, it will be like this. The reflecting surface of the concave mirror will be bent inwards. It will be bent in the inward direction. What is what I'm trying to say? So it will be used in the shaving mirror, right? You guys know shaving mirror or the makeup mirror. So concave mirrors are used there. So concave mirrors, it will be used in the shaving or the makeup mirror. So shaving or the makeup mirror, do they form a small image or do they form big images? Yes?
Small.
What, sir?
No. Shaving or the makeup mirror, do they form small or big images?
Big.
Big images. Now, like Khadija, if they were to form small images, it will be inconvenient to use them now. Getting it? So all these three mirrors are different from each other in some way. In the plane mirror, image of the object formed will be of the same size as the object is. If the right now, the size of the image will be same as the object in the plane mirror. Getting it? In the concave mirror, the image form will be smaller as compared to the object in the convex mirror. I mean to say, actually, in the convex mirror, image form will be smaller. And where do we use the convex mirror? In the rear view mirror. No, it is used as a rear view mirror or the side view mirror in vehicles, in cars. And concave mirror, it is curved inward. It is curved inward, and it will be forming bigger images, and it is used in shaving mirror or as makeup mirror. Okay, so that's all about the mirrors and their types. You guys answer this question.
Sir?
It's a reflection of light.
No, read the question once again. Yes, Gauri, you were saying something.
Sir, can you explain that again?
Which one, concave or convex, or all of them?
Both.
Both. Okay. See, basically the thing about the concave mirrors now. See, you can take a spoon, for example. To understand this now, take the example of a spoon to understand this concave and convex mirror. So if you were to hold the spoon like this in front of you, for example, take a spoon like this. Okay, you're holding a spoon like this. So this portion, which will be curved inward, that will be the concave. A spoon is a shiny object, so you can consider this as a mirror for a while. Okay, and the back portion, which is bent outward, getting it, which is bulging outward, you can understand that one as the convex mirror. Getting it? Okay, no? Getting it, all of you know what I'm trying to say. Also, you guys would have noticed that if you guys were to ever have you guys done this, like if you were to hold the spoon in front of you like this. So if it's a shiny spoon, so an image will be formed. If you were to hold it like this, the curved portion is facing towards you. So you'll be observe that an inverted image is formed there. Have you guys noted that? Notice this thing. An inverted, upside down image is formed. So the side of the spoon in which the upside down image is formed, that is the concave mirror. The front portion basically, which is bulging inwards. And when you will be holding the back side of the spoon in front of your face, so then a straight image will be formed. It will not be an inverted image. Getting it now? So you can understand this with the help of a spoon. This front bent inward portion, that can be understood as the concave, and the back portion that is bulging outward, that you can understand it as the convex mirror. Also, what I will say that the case of a concave mirror, the images that are formed, in the case of the convex mirror, the images that are formed are smaller images. Smaller images are formed. And in the case of the concave mirror, bigger images are formed. So that is the case about these two types of mirrors, these three types of mirror particularly. So in the case of the plane mirror, what I have told you that the image will be of the same size as that of the object. Their size will be same. But in the case of the convex, the image will be smaller as compared to the object, and as for the concave, the image size will be bigger as compared to the size of the object. Later on, sometime later on, we'll be revisiting these concepts in detail. We'll be learning about how the light is converging and diverging, all those things later on. But this was just a small introduction to the topic. The main thing we're going to discuss is about the laws of reflection of light as of now. Okay, now? Because we have to learn later on, we have to learn about how image will be forming in a plane mirror. See, how image will be forming in a plane mirror, we have to learn that in detail. Okay, so we'll be picking that topic after some time. You guys answer this question.
Sir, a mirror.
What about others? Is it true or false?
Their mirror.
That is mirror indeed. Good. Now, maximum part of light will be reflected by, you guys think about this. If you were to hold a piece of paper, say that this is a piece of paper. Paper is transparent, translucent, or opaque?
Opaque.
No. Paper is translucent now. Yes. If it's not a very thick paper, so it will be acting as a translucent object, which will allow partial amount of light to pass through it. And here you are having a mirror, for example. So mirror here is a opaque object, right?
Yes, sir.
And then you have a paper, or say you have a glass of water here. Glass of water. You guys read the question and then think about it. The
That
question
is
is
a
saying
object.
Opaque.
opaque object. Exactly, no? Because what will happen through the paper, some of the light will be passing through the paper. But in the case of this opaque object, consider mirror, all the light will be bouncing back. It will be reflecting. And here in this case, it will be bending. Diffraction will take place in the case of the glass of water. Now, before we discuss about the laws of reflection, there are some important terminologies we should be familiar with. Incident ray here, basically, the ray of light that will be falling on the surface will be called as incident ray. That you can see here, this arrow is showing that this light ray is incoming here, incoming to the surface here. So that will be called as incident ray of light. And the ray of the light that will be getting bounced back, that will bounce back after getting reflected, that will be called as reflected light. Got this now? Further, this line, this dotted line, is an imaginary line which we are drawing perpendicular to the surface of the mirror. This is a plane mirror, and we have drawn a line perpendicular to this. Perpendicular is drawn at an angle of how much?
90 degree.
90 degree. Exactly. So this is your normal line which you have drawn perpendicular to the surface of the mirror. Okay. And what kind of mirror? A plane mirror particularly. Okay, now a plane mirror. That is something. Further, the angle that will be formed between the incident ray, this incident ray, and the normal, that will be called as angle of incidence. So this, by the way, this symbol is called as theta. What do we call this? This is theta. THETA, theta. So theta 1 here is basically angle of incidence. Angle of incidence. In short, we also denote it like angle I. Okay. And the angle formed between the reflected ray and the normal, that will be called as angle of, what do we call this? Angle of reflection. And that can be denoted by angle R, small r. Got this now? So that is theta 1, basically angle of incidence, or theta r is basically angle of reflection. Okay. By the way, theta is used to denote very angles of very small magnitude can be used to denote, can be denoted with the help of theta. Okay. So the angle of incidence we have learned, and the angle of reflection we have learned. Is there any question from this?
No, sir.
No, sir.
Now let us learn about laws of reflection. Before we learn about laws of reflection, there are a few videos I would like you guys to see. Take a look at this here. Consider this as any source of light, like a torch light, for example, or a laser light. It is falling on this. After falling, it is getting reflected. Okay, that is quite obvious here. The other important thing here, you guys take a look at this animation here. Just 1 minute. So there's a protractor, like a protractor shape is drawn here. And you guys would have noticed that the angle at which light ray is incident on it, at the same angle it is getting reflected. The red light and the green light, observe that. I'm playing this again. It is incident at 30 degree and got reflected at the 30 degree. Incident at 45 and got reflected at 45. Getting what I'm trying to say? So this is what happens in the case of the reflection. The incoming ray of light, it will be incident on this. It will be forming an angle with the normal. Okay, it will be forming an angle with the normal called as angle of incidence. Whatever will be the angle of incidence, same will be the angle of reflection as well. Same will be the angle of reflection as well. In the animation, in this animation, you saw that as the angle of incidence here, like the incident ray of light is 1 minute here. The 0 degree, you guys can assume that as normal. Okay, now this 0 degree that is shown here, assume this as the normal. Okay, getting it? Assume this as the normal because it is perpendicular to the surface of the mirror here, and this is forming 30 degree angle with the normal here. 30 degree angle is formed, and the angle of reflection is also 30 degree. So angle I is equal to angle R, isn't it? Now take a look at the other one here, this green light. So can you guys tell me what is the angle of incidence for the green light? Isn't it quite obvious?
45.
45 now. So it is 45, and angle of reflection was also 45. Got this now? So that is what the first law of reflection says. Light also reflect added if. Yeah, of course it can get reflected from any angle here. Apart, like this is just an example, Roni. Okay, na? This is just an example. It can get reflected from 60, from 70, 71, 72, any angle. Okay. So that is the case. The first law of reflection says that the angle of incidence, that is angle I, is equal to angle R. And when this law of reflection will be applicable, if reflection is taking particularly from the plane mirror, there it will be more understandable clearly. Okay. Now take a look at the second animation here. This picture over here. Now take a look at this. This incident ray, this reflected ray, and the normal. This incident ray, the normal, and the reflected ray, all of them are lying in the same plane. All of them are lying in the same plane. You guys try to observe this one here. So in the second law, second law of reflection says that the incident ray, the reflected ray, and normal at the point of incidence, all of them lie in the same plane. Plane, you guys understand what is a plane? PLA, any planes?
Yes.
So in mathematics, how do we define plane? Basically, a 2D surface is a plane. A flat 2D surface is a plane, no? So this is a flat 2D surface here. Okay, this is not actually there, but it is an imaginary plane here. This is an imaginary plane to make us understand the second law of reflection of light. Getting it? No? So it is like this, meaning that you can understand it like this. Say that this is the angle of reflection. Is it visible? No, 1 minute. Say that this is the angle of incidence, for example. This is angle of reflection, and there is the normal. Okay, na? And all of them are lying on the same plane. It means that all of them are lying on the same plane. It's not like they are disoriented, like this is like this or this is like this. All of them are like this. If you were to observe, if you were to change the angle of view, so you can now notice this. Getting what I'm trying to say here? So that is what the second law of reflection says that. Chakrika, you understood this? Gauri, Roni, Khadija, and everyone, Abdullah?
No, sir.
Not getting it. Okay, let me take a piece of paper here. You guys give me a minute. I'll be showing it in a minute, okay? Give me a minute. Meanwhile, you guys let me know, the first law was it clear to everyone? The first law of reflection?
Yes, sir.
Yes, it was clear. So state the first law of reflection, which we have just discussed moments ago. Yeah, it's not that difficult, guys. We just learned about it moments ago. The angle of incidence, the angle of reflection, both of them are equal to each other, right?
Yes, sir.
So if angle of incidence is, let's say, 45, the angle of reflection is 45. It's like that. Okay. Okay, hope this will help you guys understand this thing. 1 minute. Okay, you guys tell me, this is a piece of plain paper, right? We can call this as a plane. By the definition, what is a plane? A 2D surface is a flat 2D surface is called as a plane, no? Right, Chakrika? Right, Khadija, everyone?
Yes, sir.
Yes.
Okay. Now take a look at this here. So you can consider the orange one here, the orange pen, as the incident ray of light. Okay, now that is the incident ray of light. All of you can see this clearly or not?
Yes, sir.
The green one in the middle, you can understand that one is the normal ray. The normal here, basically, not the ray, normal. And the other one, no, the third pen, that you can understand as the reflected ray. So are all of them not lying on the same plane? Are they on a different plane, or all of them on the same plane?
Same plane.
Same plane, no? So that's what the second law of reflection of light says, that the incident ray, the normal, and the reflected ray, all of them lie on the same plane. Hope that much should be clear to everyone. Okay. So that is the case of the law of reflection. You guys will be required to memorize it. Okay. Before we continue further, we are going to do some questions on this. So from the first law of reflection of light, let's do some questions. I'm going to draw some diagrams, and using the law, you have to tell me the values of the angle here. This shaded portion represents the back side of the plane mirror. Okay, now this shaded portion, it represents the back side of the plane mirror. Okay. Yes. What is angle R equal to? All of you write down your answers in the chat box. That's question number 1. It is very easy. Question number.
So what is written in blue?
Yes.
So
Yeah.
what is written in blue?
It's not visible. 1 minute. This one is 45 degree. Okay. And this is angle I. This is angle R. You have to tell me what is angle R equal to. Okay. Yes, Chakrika, you have answered, and Roni, you have not answered it yet. Okay. Yes, that is correct, Chakrika. Now take a look at this question here. If let's say that this is 30 degree, this is 30 degree. So you guys tell me what will be angle R equal to. Angle R will be equal to what? We don't know what is angle I also. Okay, now do tell me what is angle R and angle I both. Yes, Gauri, Khadisha, your answers are correct for the question number 1. Roni, you haven't shared it. Abdullah, you also haven't answered it yet. Answer the first question quickly. It is very simple. As for question number 2, that one is also simple. I'm not saying it's difficult. No, Gauri, for question number 2, that is not correct. Abdullah, yeah, it is correct. Yes, Chakrika, well done. That is correct. Basically, remember, this is the normal, and the angle between the normal and the plane mirror, how much it is. Everyone knows this, I think.
So I didn't get the second question.
Not getting a second question. Okay. No, Roni, that first one is correct, Roni, but the second one is not correct. Yeah, Abdullah, for question number 2, it is correct. Your answer is correct. See what is there. So first of all, you guys take a look at this angle here. What will be the magnitude of this angle? What will be the value of this angle? The angle formed between the normal and the plane mirror. Will it not be 90 degree?
Yes,
Yeah,
sir.
as we have learned that the normal is perpendicular to the plane mirror. This is the plane mirror here. So it is perpendicular to the plane mirror, meaning that it is making an angle of 90 degrees. So if this complete angle is 90 degree and this much is 30 degree, this much is 30 degree as mentioned here in the question. So 90 minus 30, this will be 60. And as per the law of reflection of light, first law of reflection, if angle of incidence is 60, angle of reflection will also be 60. So both I and R, both of them are 60. Is that clear to you and to everyone?
Yes, sir.
Khadija, you got it, no?
No, sir.
Not getting it. Okay, let me help you again there. See, basically what we have done that Just 1 minute. Say that this is a plane mirror, okay? And this is a imaginary line which we draw perpendicular. Perpendicular line basically means that when a line is drawn onto a surface at an angle of 90 degree, this angle is 90 degree. This much is 90 degree, okay? Further in the question, it was stated that this is an incident ray, this is a reflected ray, right? And this angle, as per the question, how much was the value of this much in the question given?
30.
30.
30 degree. So this much is 30 degree, and the measurement of the complete angle, as we know, this complete angle is 90 degree, and this much is 30 degree. So this remaining angle we are trying to find here, no? This remaining angle, 1 minute. This much we are trying to find here. So will it not be simply equal to 90 minus 30, and that will be 60 degree,
Yes, sir. 60
right?
degree.
Exactly. And that angle which we are talking about, it is basically the angle of incidence now. And if angle of incidence is 60 degree, so angle of reflection will also be 60 degree as per the first law of reflection of light, which says that angle of incidence and angle of reflection are equal to each other. Khadija, you understood this or not? Please let me know.
Yes.
Oh, okay. All of you answer this question in the class only. That is
No, no.
right. So that is normal basically. How many laws of reflection we have learned? Yes, Roni, that is correct.
Mm.
Yes, Khadija, Abdullah, how many laws of reflection we have learned? That is 2. Good. The angle of incidence is always, yes, Roni, that is correct.
Equal.
Always equal, exactly. Okay. Answer this one also. The angle between the reflected ray and the normal. What do we call that? Yes, Chagrika. Correct. Just write the option number or just tell me in the class. You guys can answer in the class also. Yes, Abdullah, Khadija, Gauri. The angle between the reflected ray. Let me draw a diagram to help you understand what I'm saying here. So say that this is a plane mirror, this is a incident ray, and this is a reflected ray. And that is the normal here. So this is angle R. Angle R for angle of reflection here, and that is the normal. And this one here is the reflected ray. This here is the incident ray. And the angle between the incident ray and the normal, that is called as angle of incidence. And the angle between the normal and the reflected ray, that is called as angle of reflection. Okay, so there were the answer. First question is
Angle of reflection.
Angle of
exactly. Yeah, Abdullah, exactly. For the second question, what you guys have answered? Yes, Roni, that is correct. Yes, Shukrika. Yes, Khadija, what's the answer for second question?
So regular reflection.
That is regular reflection. Everyone, your answers are correct. Okay. So you guys answer this question as well. Like, which of the following results in a diffused reflection? Diffused or scattered, in which the reflected rays will be scattering. Like the incident ray, are they are always incident parallel. The incident ray will always be parallel to each other, but the reflected ray, they will not be parallel to each other in the case of diffuse reflection. Yes, that is correct, Chukrika. Everyone answer this question. Simple question. Yes. In the case of diffuse reflection, what have we learned? That it occurs from a rough surface now. Silver, Khadija, it's a smooth surface now. Silver is a metal and has a smooth surface now. So regular reflection will be taking place from silver, right? Plane mirror, from that also regular reflection, shiny surface also. But wood has a rough surface. It has a texture, rough texture, has a rough surface. So those of you who are answering wood, that is correct. Got this? Now let us learn about the formation of image by the plane mirror. But before that, I would like everyone to state the two laws of reflection. Starting from Abdullah, you quickly. Everyone will be answering it under 1 minute. Don't take more than 1 minute to answer it. Okay? Yes, Abdullah, start. Mention the two laws of reflection of light.
Where the first law is the incident ray which is reflected at the point in the same place is called.
No, 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 no. You're mentioning about the second law, but that is not proper. You're lacking some important points in that. Okay, no worries. Try again.
The when the reflected ray states that the I can't remember the incident ray.
Okay, okay, no issue, no issue. We'll be learning about that in a minute. Roni, you're having audio issues again. You can type in the chat box then. Gauri,
So the first law is that the angle of reflection is equal to the angle of incident ray.
reflection angle of incidence is equal to angle of reflection. Okay.
Okay,
And next law is
is that the incident ray, reflection ray, and the normal to the surface of the mirror all lies in the same place.
or plane, not place.
Sorry,
Place
plane.
will be a different thing then. Plane basically a 2D surface. We are referring to as plane. Okay, next, Chakrika.
So the first law states that the angle of incidence is equal to the angle of reflection.
Good.
And the second law states that the both incident ray and the reflected ray will lie on the same plane.
You forgot about the normal.
Yes, sir, and the normal.
So incident ray, the normal, and the reflected ray at the point of incidence. It is important to say at the point of incidence. So the incident ray, the normal, and the reflected ray all lie in the same plane. All lie in the same plane. Okay. Khadija is not here now. Okay. So next we are going to learn about formation of the image by the plane mirror. Okay, now. So consider that this is an object given over here. This is a person given over here. This must be having some height. Let's call that this person is having a height of h. Okay, now let's call this person is having a height of h here. Okay. So it is placed at some distance from the mirror, right? Let us say that it is standing at a distance d from the mirror. So when the rays of light from the when the rays of light from this person will be falling on the mirror, so the image of the person will be formed inside the mirror here. So we can consider that the incident rays incident rays are falling on the mirror like this here. Getting it? Or to understand this, you can take this one here. Let me just draw some diagram over here that will give you a better clarity. Okay. Say that this is a mirror. Whenever we draw a plane mirror, it is important to shade the back portion like this. Okay. And say that this is an object. I am denoting an object with the help of an arrow here. Okay.
Sir.
Now consider that this object, let's call this as AB object. The top portion of the object, I am calling it as A, and the bottom portion of the object, we are calling it as B. And this must be having some height. Let's call this as height H, right? And let's say that some light ray is falling onto this object here. Light from the sun, light from the torch or something will be falling on this. So after falling on this object, it will be getting reflected from the object now, from this object AB, isn't it? So there will be a light ray that will be coming from the top portion of the object like this. Getting it, guys? Like this. And there will be another light ray that will be falling in this manner. That will be falling in this manner. Getting it, guys, so far? So we have considered an object AB of some height H, and also it is standing at a distance. Let us say that it is standing at a distance U from the object. We call this distance U. It could be 1 meter, 2 meter, 1 centimeter, anything, okay? Further, consider that there are some rays of light that is coming from this object, and it is falling on the surface of the mirror here. Getting it, guys? So consider that a ray of light by the name of AP is coming from this object. You guys understanding so far what I have told you? So far everything's clear or not? Please let me know.
Yes, sir. It's clear.
Let me erase this arrow to avoid confusion. Also, you guys know, just like how you name the rays in mathematics, so in that manner I have named the ray also. This is a incident ray of light which is falling on the mirror. So the incoming ray of light, basically incident ray of light, it is AP that is falling on this mirror here. There are other rays, incident rays of light also. That is another one. We can call this as AO. AO. And let's take one more. So one more light will be coming from the bottom of the object also, no, like this. So let us call this as BO. We'll be calling this one as the BO. Getting it what I'm trying to say? That will be called as BO. So these are all the incident rays of light that is going to fall on the mirror here. We can name this mirror as M dash. We can name this as M dash. Okay. Now, as these reflected rays will be falling from the mirror, so it will be getting reflected back also, isn't it? Reflection is going to take place from the mirror now.
Yes, sir.
Right. So reflection is going to take place, and it is going to take place in this manner. The reflected rays I'm going to draw in draw using a different pen here, different color pen here. Getting it? So let's do one thing. Let's first draw some imaginary lines. These are imaginary lines. The dotted lines which I'm drawing, these are the imaginary lines. Okay. Why? Because the light rays are not actually passing through the mirror. Does the light rays pass through the mirror? No. They will be getting reflected back. So as the light ray are falling onto the surface of the mirror, so this is falling directly. It is falling perpendicularly. So it will getting reflected back into the same direction from which it came. It will get reflected back into the same direction from which it came. Getting it? What I'm trying to say here? If it is falling on this plane mirror at 90 degree, it will get bounced back at 90 degree, following the law of reflection. Now, angle of incidence is equal to angle of reflection. But what I have done here, I have drawn this line further back into the mirror. So I'm drawing the dotted lines here. Okay. Now take this one also. I mean to say this one. This BO. Take this line BO. This incident ray of light BO. That will also get reflected back now. That will again get reflected back in the same direction from where it came. Let's draw this one also further into the mirror like this. Is that much clear so far what we have done here?
Yes, sir.
Okay. Further, at this point, join the dots here like this. Like this. This is where the image formation will be taking place here. This is where the image formation will be taking place here. Further, let's take this one also here. This ray of light that is falling AO, that will also get reflected back, isn't it, guys? So that will get reflected back like this now. following the law of reflection, it will get reflected back like this. Let's call this as OC, ray OC. So let's join this back in the backward direction like this. Like this. Getting gas. Let's join it back like this. And as for and there will be some other rays also coming from the surface of the object, like let us say that this one is also one such ray. This is another incident ray of light that is coming from the object here and falling onto the surface of the mirror. So this will also get reflected back following the law of reflection. It will also be reflected from the mirror, isn't it?
Sir.
And let's draw the dotted lines back towards the back of the mirror like this. So when you will be meeting, or when all these dotted lines will be met, so the place where all these dotted lines will be met, there the image formation will take place. There the image formation will take place, as you guys can notice here. And that will be calling as A dash B dash. And the property of the image will be as follows. The image form will be of the same height because the image formation is taking place from a plane mirror, right? And also the distance will be same. This one will also be U, right now. So what we will observe here, that the image AB will be of the same height H. That is one of the characteristics. But further, the distance between the image and the mirror will be same as the distance between the object and the mirror. It will be always equal. Image is upright and it is erect. It is not upside down. It is upright and it is erect. Okay. But it will be laterally inverted, which we'll be learning in next class, like what is lateral inversion. What is lateral inversion? We'll be learning about that. Lateral inversion, basically you can take like this image. The left side of the object appears to be right, or the right side of the object appears to be left. So that is something we should be learning in the next class. From here, we'll be discussing this thing again once in the next class. Okay, no? I know some of you might not be getting this, so we'll be relearning about this in the next class.
Okay, sir.
Okay, then.
Okay.
Bye,
Sir.
sir.
Yes, bye.